Welcome back. If you watched the last video, we did questions 1 and 2, and hopefully in this video, if all goes well, we'll do questions 3 to 5. So the table shows a summary of the results of a long jump competition. The distance jumped is shown here, the frequency in the next column. We need to find an estimate of the mean distance jumped. You may use the extra columns in the table. The first instant thing that comes to me is the word estimate. This is a key word, to be honest. So we need to find an estimate of the mean. Now you should probably be familiar with this formula. You don't have to be, and I'm just going to write it for the sake of it because I think it's a useful thing to know, is that the mean, which is x bar, is equal to the sum of the midpoint multiplied by each frequency over the sum of the frequencies, and this is just sigma, which is equal to the sum. So they've given us 2 extra columns. How nice of them. So we'll just use them, and it's up to you what you want to use them for, but to me it makes sense to find the midpoint. So like so, and I'll still label this x, to be honest, and then this should be the midpoint times x, which I'll just call f of x. Now when you look at the midpoint, what is it exactly? Well, it's the midpoint between each of the intervals. So 7.1 and 7.3, you can clearly see here that is 7.2. Now how would you do it for a more complex one? Well, you just do 7.1 plus 7.3 and you'd find the mean. That would give you 7.2. So I'm just going to write them all down quickly now. Now I've done that, f of x is literally equal to f multiplied by x. So using your calculator, well, you can have a go right now, type these all in and write their respective values in. Okay, so I've got my values now, and I'm going to just write them in. So you should get, for the first one is 7.2, then you should get 14.8, then you should get 38, 70.2, 64, and 24.6. Now you've got a sum of x times f, or f times x. I've written it the wrong way around here, or the other way around. There's no right or wrong. I'll just sum them up, which is what this means. So I'm just going to use the formula and find the sum of all of these. So I'll do 7.2 plus 14.8 plus 38 plus 70.2 and so on. And go ahead and type this into your calculator. And one more thing, some of the frequencies, probably should have done this first. And 1 plus 2 plus 5 plus 9 plus 8 plus 3. So for the numerator, I just calculated this now and I got 218.8, and used the calculator to find the sum of the frequencies. And as always, don't do these in your head. You've got the calculator for a reason, you might as well use it. You should get 28. So 218.8 divided by 28, sorry. And that gives us 7.8142857. And does it tell us what to round it to? I don't think it's a big topic of what you should round it to, but seeing as most of the values given are to 2 significant figures, I'll just stay with that, and I'll keep it at that. And the 2 significant figures, this would be 7.8 meters. And yeah, remember to give units. They've given it for this question. However, it's a good habit to get into. So you should have 7.8 meters as your answer. For part B, we're told to draw a frequency polygon for the data. So let's highlight our keyword, and here it's frequency polygon. Now a frequency polygon, the idea is that at each frequency you draw the frequency matching to the midpoint of that interval. Sounds confusing, but let's just do it and it should make a bit more sense. So we need to first look at the graph they've given us, and they've given us the horizontal axis, but they've not given us the vertical axis labels or anything like that. So that's probably going to be what we need to do. So on the vertical axis, we're probably going to want to put frequency. Now let's go back to the table where we see that the highest frequency is this value here, 9. So with that in mind, what would be the best scale to use? If there are 10 squares, then it's probably better to increment by 1 and go up to 10, which would kind of accommodate all of the different values that we have for our frequencies. So I'm going to go in ones. So now we've done the axis and the labels, we now need to focus on the actual frequency polygon itself. So at each midpoint, and the midpoints we have, we've labelled them all 7.2 through to 8.2, we need to plot the corresponding frequency. So at 7.2, which is our x value, we need to go to the frequency which matches it, and that's 1. So I'm going to plot that here. Now we go to 7.4, and we have 2. For 7.6, we have 5. For 7.8, it's 9, which is our highest value. Now for 8, it was 8. And for 8.2, it was 3. Okay, now the important thing I need to mention now is that you always connect the midpoints to each other using straight lines, which is why I've got my ruler. It's going to be interesting how we use this. Yeah, there's not much more to it other than you just join them in straight lines and make sure the midpoints are touching, to be honest. That's all I can offer. Okay, kind of messed that one up. That's kind of good enough. You should, with more accuracy, with a paper and pen, hopefully do better. And I recommend doing it in pencil and then tracing over afterwards, because you don't want to make a mistake in the exam, do you? So part C asks us to describe any skew, if there is any, shown by the data. Now this is another thing that you must know, so I'll just draw quickly 3 different types. What you see here are 3 different types. This is negative skew. This is symmetrical or no skew. And this is positive skew. Now, it kind of goes against what you'd expect. The one with a almost positive gradient is negative, and the one with an almost negative gradient is positive in terms of skew. And it's kind of confusing when you first look at it, but over time, as you do more questions, you just get used to it. And so you just have to think of it as almost opposites to each other. And that's what I do. And you can see with here, the general shape, it kind of follows an upward sloping, like so. And that kind of matches this graph here. So we can kind of say it's a negative skew. So yeah, that is what I'm going to put, a negative skew. Question 4. The pie charts show information about the departure country of the overseas visitors to the UK in January and July of 2016. Based on the 2 pie charts, Rule makes these two conclusions, that there are more visitors from Europe than from North America in both months, and that there are more visitors from Europe in January than in July. Assess the validity of each of his conclusions. Let's focus on one first. There are more visitors from Europe than from North America in both months. So North America is the slightly darker shade than Europe, and we can see that Europe has a larger share of each circle than North America, so it represents a higher proportion. So the claim that there's more visitors from Europe in both months is true, even if the size is different, which we might come on to later. As long as the proportions are different within the same one, we can confidently say that there are more people coming to Europe, or going to Europe, whatever the context, than in North America. So I'm going to put that Roll's claim here is valid due to Europe. Oh, terrible spelling. Having a higher proportion than North America in both months. For part 2, or the second one, he says that there are more visitors from Europe in January than in July. Well, look, there's no numbers here given to us. We're just given the dates and nothing else. So it's actually impossible to say. So to be safe, you meant to say that it's invalid because, well, the size here, they're not comparative pie charts, which ironically the next part is about. However, you can't assume that here, and so therefore we don't know if there were actually more in January than in July. So we'd put invalid, and then literally the answer that I gave is that they show proportions rather than the actual numbers of visitors. Now Judith decides to replace the pie charts with comparative pie charts. Explain how comparative pie charts are more appropriate than pie charts to compare the number of visitors in each month. But one thing that you naturally expect is that the exact same number of people will not be going overseas in the same month, different months, So you're not going to have exactly 10,001 in both months. You might have a slight variation, maybe a lot of variation. Either way, they're not going to be the exact same. We can write that comparing the areas would effectively compare the numbers. Part C now. The total number of overseas visitors to the UK in January 2016 was 2,599,000. The total number of overseas visitors in July of 2016 was 3,786,000. Judith's comparative pie chart for January 2016 has radius 3 centimeters. Calculate the radius of her comparative pie chart for July 2016, given my answer to one decimal place. So this is going to utilize another formula. Now you don't have to use a formula, there is another method, and it kind of derives this formula, and you can think about it using intuition if you like, but in the exam you're just going to want to plug in the formula, and that's what I'm going to do here. I'm going to give you the formula. So the formula is the square root of f2 over f1 is equal to r2 over r1. Now what does exactly all of these mean? So f2 is the second frequency, f1 is the first frequency, r2 is the second radius, and r1 is the first radius. Now look at the question and just see what information you've been given, and just look for the numbers. Here we can see this, and this. They just stand out to me. They don't particularly mean anything at this point in time. But you can see that this and this, the top and the bottom pieces of information, they link. They're both for January 2016. And you can kind of see that they link together. If the radius is 3 for January 2016 and July 2016 has a higher population, well, the previous question just indicated that we use the areas to compare the numbers, so the radius naturally should be different, and we're going to basically link the radius using these. It's kind of complicated. I'm going to try and just do the question and it should make more sense. The best thing to do here would be to assign each of these. So for January 2016, we have 2599000, and also the radius is 3 centimeters. For July 2016, we have the following number, and we don't know the radius, so the radius is unknown. You can go with whatever you like, but the general thing I go for is to assign R1 and F1 to the one that you have information for both parts, which is here, January 2016. We have information for the radius and information for the frequency, so I can assign these the values of F1 and R1. You don't have to give it this, but it makes it much easier in my opinion. So therefore, for July 2016, it would be R2, and for July 2016, the frequency would be F2. Now, using this formula, we just have to plug and go from here. So the square root of F2 over F1. F2, as we know, is 3,786,000 all over 2,599,000. And this is equal to the second radius, which we don't know, over the first radius, which is 3. And you can see that I've kind of used all of this information here. I'm going to move it to the side. And so now we can kind of use this in order to help us find R2, which will be the radius of July 2016. So it's just a bit of rearrangement here. I'm going to bring it to this space here so it's much easier to see. So R2 should equal, and if you've imagined this bit is dividing, you're multiplying by the 3 in order to eliminate it. So we'd have 3 lots of the square root of all of this. And then you just have to type this into your calculator. And what you end up getting is this following. The question tells us to give our answer to 1 decimal place, and so doing this, we need to put this to 1 decimal place, which is equal to 3.6 centimeters. This question is quite a big one, and my only advice here is to keep practicing these types because, honestly, this is the only way you can get better at it. So, a database contains information about the 2,567 people registered at the medical center. Here is the information that the database contains on each person: the name, date of registration, etc., etc. Now, you should notice that they've given this for a reason. It's just not random information to throw you off. They've given it for a specific reason. So Rebecca wants to see if there's a relationship between the age of a person registered at the medical center and the number of appointments this person has had at the medical center. Describe how Rebecca can plan to use technology to help her process and present the data for this investigation. You should refer to the advantages of using technology to process data compared to doing so by hand. And this is a key piece of information that you really need to know. So refer to advantages of using technology compared to by hand. And then another thing is you can split this into describing how Rebecca can plan to use technology and the advantages of using technology. So advantages and planning to use technology. So there's kind of two pieces of your answer that should be, so there should be the plans to use it, what you can actually do with the technology, and the advantages of doing so. And basically, because it's 6 marks, you're going to want to go for a rough 50-50 split. So you can do 3 general points per heading. So if we look at the planning, what can we do with this data? Well, we know that there's 2,567 people, which is a lot. And Rebecca's aim is to see if there's a relationship between the age of a person and the number of appointments. So she's going to have to select people, right? So how can she do this? Well, we can use simple random sampling. If you don't know what that is, please do revise that. I've got a video on that. After assigning people a number, you need to generate random numbers. And this is something that technology is great at doing, because other than doing it with a hat, there isn't really any other alternative other than technology. So we can write that it generates random numbers. Now, the last bullet point here makes this more focused. You should refer to the advantages of using technology compared to doing so by hand. So compared to doing this by hand, and let's just say for the sake of it that we're using a hat instead of a random number generator, what's the main advantage here? The first thing that comes out to me is that it saves us time. So it saves time. And that makes sense because technology is meant to automate the process and make it a bit more quick. So that's basically a point and an advantage to go with it. So the next one we can think about is, well, look at all this information given. She just wants to know about the age of the person and the number of appointments. So all of this here, the name, the date of registration, the phone number, etc., this is all irrelevant information. So we can kind of say that the technology will remove irrelevant information and what does this make? What's the advantage here? Well, it makes it easier to read the data, and as a result of being able to read the data and therefore correct mistakes. So that's another plan of using technology, removing irrelevant data, and an advantage to go with it. So that's kind of 4 points there, which is 4 marks. So we need one more set of 2. And the next part is that while technology can remove outliers. And while the mark scheme doesn't say appropriate, sometimes you just genuinely have a piece of data which might seem like an outlier, but it's not actually an outlier. For example, if you're looking at people's heights and there's this really lanky guy, you're not going to just take him out of all your data because it is lanky and it doesn't fit your pattern. He's a genuine lanky guy and you have to make him feel included, So you have to keep some outliers which make sense. Only the appropriate ones that shouldn't be in the data, you remove those. And technology is good at doing that. And what is an advantage of removing outliers? Well, this makes the data unbiased. So that's kind of 6 marks. I'll kind of highlight or show how many marks. So from these two, basically where it's splitted with the comma, you'd get a mark each. So it should be 2 marks from this part, 2 marks from this part, and 2 marks from this part. There are some more other things that you could think about. For example, ordering the data by the ages or the number of appointments. You can also remove extraneous data, which is just irrelevant data, by the way. I forgot to mention that. Irrelevant data is another word for extraneous data. You can identify missing data. You can automate the production and calculation of summary statistics. And on the other hand of this, what else can it do? It can reduce errors in the calculations and it makes data more visually appealing, though I wouldn't really go with that, and I wouldn't have thought of that anyways, that last one. So if you did enjoy this video, please do leave a like, as it motivates me to make more videos, and do let me know in the comment section below if you want me to make more of these, as I'm trying to go through the whole paper. It's taken me a bit of time, and yeah, just to get it to this high level of accuracy, you know, I have to make sure that I'm not giving any false information about the mark scheme. So please do let me know if this is useful to you. If not, please do tell me where I could improve, because I genuinely appreciate the feedback.